Hi, so in this lecture we'll see the array modules of Lodash that contains functions of arrays. Lodash contains a lot of functions for manipulating arrays in various of tasks. We'll see some of them to demonstrate the usage. We wouldn't see, of course, all the functions because there are a lot of them and there is no point in that. I just want to show you some of the interesting functions and I hope it makes you curious enough to go and figure out by yourself some of the other functions as you need. So the first function I want to show you is a chunk. The chunk function accepts two parameters, an array and a chunk size. The function returns a new array where the elements from the original array are in sub-arrays, which are called chunks, with the desired size. Let's look at an example. If you want to activate the lodash function, we use the underscore namespace. The underscore is the origin of the name lodash because lodash is actually an alias for underscore. So we're writing underscore dot chunk, and this is activating the function chunk. And now I'm passing this array, the 1, 2, 3 until 7, and 2, which means I want to take this array and partition it into chunks of the size of 2. So if I'm printing out B, I'll get this array. You can see that each two elements are gathered together in one chunk, beside the last chunk which contains less or can contain less than the two elements according to the array's length. The size parameter's default value is 1. So if we wouldn't mention the chunk size, we'll get just an array that is contained inside the first array. Another interesting function is the difference function. It accepts two or more arrays, and this function returns a new array contains only the elements from the first one that are not included in any of the other array, a difference function. So example, if we have this A array, and I'm activating the difference by underscore.difference and passing the A array and the second array 1 and 5, B array would contain only 2 and 4, which are the only elements in A that are not included in the second array. Take a note that the 1 value appears twice in A, but nonetheless all of its occurrences are deleted from the result. And if I'm doing something like that, B equals to underscore.difference A, and then I'm passing two arrays, I'll get in the result only the elements from A that are not included in either the arrays that appears as parameters. So in this example, only the number 2 does not appear in either of the of the arrays. A slightly more interesting version of the difference function is the difference by function. This function also accepts two or more arrays, but in addition it accepts another parameter which is a function. Let's call it evaluate. The function returns a new array, contains only the elements from the first array that after invoking the evaluate function on them are not included in any of the other arrays, again after invoking the evaluate function. It sounds pretty confusing, so let's see an example. Suppose we have this array, A array, that contains some real numbers. Now I can activate the difference by function and passing it the A array and this second array, but I'm passing also the third parameter, which is parseInt. ParseInt is a standard JavaScript function that accepts a number or a string and returns an integer. So now the result of B would contain only 7.1. But this result may look a little bit odd because if you take a look, you can see that there is no value in A that appears in the second array. So actually, we would accept if we would activate the difference function that the result would be the original array A. So let's look what is happening here. First of all, the function takes the original array and takes the first value, 6.5. Now it activates the function parseInt over it and get the value 6. Now it goes to the second array and activate over its values the function parseInt. So it gets those values. Now you can clearly see that 6 indeed appears in the second array. So 6 wouldn't be in the result array. So actually what the function does is just filter or taking the values inside the filter, and according to this filter, according to this function, checks if the values are presented in the other array. So now you can see that 7.1 is the only value in the A array that is not in the second array. So let's see a little exercise of using this function. Given a list of users in our system, each user is represented as an object like that. We have an object with three attributes. The first one is the first name, the second one is the last name, and the third one is the username. Now suppose we get another list of usernames that was active in the last month. The list is built out of objects that look like that. We have object that has only one attribute, which is the username. Now we want to extract the user that wasn't active in the last month. The algorithm here is pretty clear. We have to go over the first list that contains all the users and find only the users that are not presented in the second list. So if we have this list, the users, that is an array of objects, and we have another list, which is the active users, that contains an array that contains only objects of the usernames, we want to take the difference between the first array, the users array, and the active users. But we cannot just activate the difference function because the format of those two values is not the same format. We have here an object with three attributes and in the second list, object with one attribute. So we can activate the difference by function like that. We define a new variable called non-active, which is equals to _difference by. We're passing the users array and the active users, and then a third parameter, which is a function that accepts a user as parameter and returns the username. So what is happening here, that we take the first user, the first element in the users array, and extract or returns only the username. And then we compare it to the username in the active users. So we actually get to activate the difference function, but with a slightly different variation. So we still can differentiate between two lists, even though the values in those two lists have different formats. Another interesting function is the fill function. This function accepts an array, value, and two indices. The function fills the array with a given value from the start index to the end index, not including. If the indices are missing, the whole array would be filled. For example, if we define this array, now we can activate _.fill a and 7, and the result would be that a is filled with 7s. Take a note that the function changed the original array. And if we take this line, _.fill a with -1, 1, and 4, now the a array would be filled with -1s, but from the index 1, 2, and 3, not including 4. So printing a would look like that. And we can do it with an anonymous array. For example, let b equals to _.fill, and now I'm using the standard JavaScript constructor for array. I'm creating here an empty array, just an array filled with 5 undefined and 0, and now the b array would be filled with 5 0. Take a note that the fill function changed the original array and also returns it. So here b gets the value. And another function called the flatten depth. The flatten depth function accepts an array and returns all elements in the array in the same level. So it flattens the array. So example, if we have this array, and you can see this array is a mix of all kinds of subarray. The first element is an array of two strings, the second element is just a string, and the third element is an array that contains two elements. One of them is a string and the second one is another array. So if we perform the function flatten depth over A and assign it into B, B would look like that. Now it contains all the elements that was originally inside a subarray, just in the same level, with no nested arrays. But we can also pass a parameter, second parameter to the function, and now with the second parameter controls to which level we want to flatten the array. In this example, we activate the flatten depth function over A and pass the parameter 1. So we want all the nested arrays in the level of 1 to be flattened, but every nesting over one level would stay nested. So in this example, we'll get this array. You can see that John and Smith were both in the first subarray, which is level 1, so they are outside, and the email john@gmail.com is stayed in the same level. And we can see that the next element was the array that contains the string CA as first element, and CA is in level 1 in depth, so it came out. But the second element is another array, so this is another level of depth. So all the elements in this array, exactly this array, is staying nested inside the result set. So this is the flatten depth function. So let's see a small exercise. Write a function called with commas. The function would accept as parameters a number num and another number d. The function will return a string represents num where a comma is presented after every d digits from right. It is possible that the leftmost group of digits wouldn't contain exactly d digits. So if we activate the with commas function over this number and the number 2, we'll get this string. You can see that every 2 digits are separated with a comma. And if we activate the same function over the same number, but now with the parameter 3, we get this result. Now every group of 3 digits is separated by a comma beside the leftmost digits. So try to think about a lodash function of array that can help you to solve this question. And you can see the result in the additional resources of this lecture. So in this lecture we saw the array module and we saw some functions, some useful functions that presented in this module. There are a lot of other functions and I highly recommend you to try and read the documentation and find some interesting function that you can use because there are really a lot of functions that perform a lot of interesting tasks over array. So see you in the next lecture.